Hello everyone, nice to see you. Last time we have seen about chapter 4, that is about measurement, basic measurements in this in epidemiology. So from basic measurement in epidemiology we have seen that measures this frequency like ratios, rates and proportion, and also we have seen measures of morbidity, that is prevalence and incidence. We have seen what prevalence means, like point prevalence and period prevalence. Then we have seen an incidence. Incidence can be classified into two: cumulative incidence and incidence density. Cumulative incidence we have already seen. Then our topic will be today's topic will be incidence density. Now just we will start incidence density and stay with us. So incidence density is incidence density is having another name which is known as incidence rate. We can say that incidence density as incidence rate, person-time incidence rate, instantaneous incidence rate, hazard rate, and force of morbidity and mortality. We can say all of this. So for instance, in the case of survival analysis, we can say hazard rate. So most commonly name is incidence rate. We can say incidence rate and incidence density interchangeably. So the measure of the speed that disease is occurring, that that measures the speed how that disease is occurring, or the speed that disease is occurring, how it is quick the disease occur. It measures like how it's quick the disease measure. So it is the speed at which a defined at-risk group or population develops a new clinical condition or outcome over a given time period. So the speed at which a defined risk group or defined population develops a new clinical condition or outcome over a given time period. So there is population, at-risk population. So incidence density measures that at-risk population by what speed develops a new clinical outcome or disease or whatever, an event. So indicators how quickly people became ill, measured in people per year. So there is duration, there is time period. So people should be followed, population at risk should be followed, and the outcome will be determined. So that is said to be incidence. So it indicates how quickly people became ill in some duration of time or in period of time. So incidence rate or incidence density it measures the rate of disease or speed of disease, measures the rate of new disease occurrence over time. So incidence density answers the question, at what rate are new cases of disease occurring in the population? At what rate are new cases of disease occurring in the population? So incidence density is equal to the number of new cases over total person time of observation. So this populations which this total person time of observation measured is population at risk. They were also at risk for one outcome. So but in the case of cumulative incidence, population at risk is the number of individuals which is at risk. But in the case of incidence density, that population at risk, those population at risk person time will be added or summed up. So the total person time of observation will be taken. So number of new cases over total person time observation times by 10 to the power of n. N should be 1, 2, or 3. That means to make to remove the decimals. So if it is n is 1, it will be 100. If n is 2, it will be 1000. If n is 3, it will be 10,000, and so on. So this is a formula for incidence density. The denominator of incidence density calculated using percent time units. So as you see it, total percent time of observation is percent time units. So percent time unit is the sum of the time that each person remained under observation. So for instance, if you have 10 individuals, so if you follow 10 individuals from the start to those disease-free individuals, those 10 disease-free individuals will be followed, for example, for 30 days. So each disease-free observation, each disease-free follow-up will be summed up as total. For instance, individual 1 is followed for 30 days, individual 2 is followed for 28 days, and individual 3 is followed for 23 days. So there is different type of some individuals will be in the follow-up, some are lost follow-up. So all time contributed by each individual will be summed up. This total summed up time is known as total percent time observation. That means an individual which remained under observation or which remained under follow-up will be summed up. In short, incidence density is the occurrence of new cases of disease that arise during percent time observation. Meaning this one, similarly this one, incidence density is the number or the occurrence of new diseases over percent time observation. So the numerator of incidence density is the number of new cases in the population. So this numerator is similar to the numerator incidence density is similar to the numerator cumulative incidence, but the difference is the denominator. The denominator incidence density is percent time observation, whereas the denominator in cumulative incidence is population at risk, the number of population at risk. This is the first one difference between them. So percent time is the time in which an individual is free of outcome after exposure. So after one exposure, individuals will be followed to see the outcome. So percent time is between exposure and the outcome, the time between exposure and outcome. So it is the sum length of time period passed free of illness or either free of illness or at risk by which an individual member in the study. So the assumption is dynamic population at risk. So by the way, in the incidence density, dynamic population at risk will be considered. For instance, individuals may start at different time period and individuals may end their follow-up at different time period. But in case of cumulative incidence, static population at risk will be considered because individuals will start at the same time. So this is a difference. So incidence density will be used for dynamic population or individuals which start at different time. So dynamic cohort is a cohort of people living and entering study at different time period. So this is dynamic cohort. So incidence density is used for dynamic cohort. Each person is observed from established starting time until one of the 4 endpoints reached. Maybe your objective is onset of disease. Until onset of disease they will be followed from starting time until onset of disease, or they will be followed from the starting time until days, or they will be followed and maybe lost follow-up. Some are followed until end of the study. So different individuals start at different time and also end at different time, maybe at days, maybe lost follow-up, maybe end of study, censored or recovery will be in different time. But also our interest of outcome of interest will be different. Onset of disease or other days or recovery, it should be different. So one that keep in mind is that in case of incidence density, the people will use dynamic cohort. That means people living and entering in the study at different time. One, the other is That means it's dynamic population. The other means the denominator is person-time observation. Person-time observation. So uses of incidence rate. Incidence rate is unimportant as a fundamental tool for etiologic studies of disease, most either for acute or chronic disease, since it is a direct measure of risk. A direct measure of risk. So incidence rate is measures a direct risk of, or a direct probability of contracting the disease. So incidence rate is unimportant for to study etiology of the study of disease. So it is important to determine risk factors or causative agents for one disease. So this is unimportant. So if incidence rate is significantly higher in one area, then the cause of that disease can be systematically searched. So describe the trends in disease, evaluate impact of primary prevention programs, useful for taking action to control disease, for research into etiology and pathogenesis, distribution of disease, efficacy of preventive and therapeutic measures, most useful for evaluating effectiveness of programs that try to prevent disease from occurring in the first place. Then prevalence is a static measure taken at point in time, for instance point prevalence. Incidence is a dynamic measure take over a certain time. There is follow-up time or follow-up period. So when compare and contrast point prevalence and incidence, point prevalence is a static measure taken at point in time or specific point in time, or incidence is a dynamic measure taken over certain time or certain time period or duration. So this is their differences. Occurrence of person time, when we see the person time, this is data which is collected some duration time in 1980, 1989 and 1999. So this is subject 1, subject 2 and subject 3. Subject 1 is followed up to X, and subject 2 is followed up to X, and subject 3 is censored. So subject 1 is followed 10 years, and subject 2 is followed for 10 years, and subject 3 is followed for 20 years. This is comes by, for instance, this individual followed for 10 years. So so we can sum each individual contribution. For instance, subject 1 have 10 years, subject 2 10 years, subject 3 20 years. So to get so our outcome of interest is X. This is outcome of interest, maybe days. This is days, this is days. So this is unknown. So the incidence rate, if you want to incidence rate is the occurrence of new cases over person time observation. To get person time observation, you have to sum these three things, these three individuals or study groups. So 10 plus 10 is 20, 20 plus 20 is 40. So 40 per year. So all individuals followed for 40 per year. So to calculate incidence rate is equal to the occurrence of new disease, that is 2, from the 3 is 2, XX, because of, since it's outcome interest, XX 2, so 2 and over person time observation. Person time observation of this study is 40, so 2 over 40 per year. 2 over 40 per year is our result or finding. So we can divide 2 by 40. So the other is some ways to calculate 100% Y. For instance, 100 people followed for 1 year each. So there is 100 individuals, each is followed for 1 year. So 1 times 100 will be 100% year. 10 people followed for 10 years, meaning 10 times 10 is 100% year. 50 people followed for 1 year, plus 25 people followed for 2 years. 50 people followed for 1 year. 1 times 50 is 50, plus 25 people followed for 2 years. 2 times 25 is 50. 50 and 50 is 100% Y. 100% Y. So time unit for person time is, maybe it will be year month or day. So some diseases, for instance, like cancer, it may be measured per year. Some diseases like neonatal sepsis, something like that, it will be measured by day. And some diseases also may take months. So the time period should be specified, but the time period maybe it will be year, month or day. So person time means person year, person month, person day. You can say just like this. So the other example is the incidence density calculation with annual observation during 7 years follow-up. So person year at risk is 41. So 1, 2, 3, 4, 41 individuals at risk. So illness, by the way, this sign is illness, this sign is illness. So two individuals is illness, this and this is censored. So this is censored individual, this is illness. So this indicates year of follow-up per year. So since 41 is person year at risk or summed up person year, so illness is 2. So incidence density is calculated 2 over 41. 2 is the number of illness, so this is the number of illness. 41 is person year followed. So 2 over 31 times 100, it will be 49 per year. 4.9 per year. 49 person year. So 4.9 person year or 4.9 PY. We can say just like this. So when there is incidence questions, first we will identify the number of new diseases or the number of occurrences. Then we should identify each person's time. Then we will add up each person's time, each person year time. So we will divide the number of occurrences over person year time times maybe by 100 or by 1000 or by 10,000. So this is an important aspect. So when we see the exercise, cohort study of the risk of breast cancer among women with hyperthyroidism. Individuals followed for 30,324 person year, and the number of individuals is 1,762, and age of 70 years of follow-up per woman. So totally 70 years time of follow-up. So in this time 61 cases of breast cancer was found. So what should be incidence rate? Please calculate incidence rate. So incidence rate is the number of occurrences times person year time. So the number of occurrences or the number of new cases is 61 over person year time. This person year time is 30,324 is person year time. So 61 over 30,324 person year. So our result will be 0.0201 per year. So or we can say, or we can explain 200 per 100,000 person year. That means rounding. After rounding of 5 times, we will get this 200 per 201 per 100,000 person year. So we can calculate by this way. The other aspect is so incidence. For instance, this is an example for incidence study. So incidence and determinants of adverse outcomes among women who were managed for eclampsia. So now we will calculate incidence and its determinant factors. So this is the the incidence of adverse maternal outcome in eclampsia mother was 53.7%. So this is an incidence. Because in this study there is 231 individuals. So there is some individuals which develop adverse maternal outcome. So those individuals who developed adverse maternal outcome divided by total population at risk. So so we will get 53.7%. This is, by the way, cumulative incidence. So this is an example for how incidence will be used, cumulative incidence. So basic requirements for calculating incidence rate. To calculate incidence rate, first you have to know the knowledge of the health status of the study population. To be able to classify people as diseased or not diseased, there should be adequate basis for assessing the health of individuals in the population. So knowledge of health status, identifying or recognizing the knowledge of the health status of the study population is very important. The other is time of onset. Since incidence rate deal with newly developing diseases, identifying the date of onset is very important. The other is, the third is specification of numerator. The numerator should be specified. So the number of persons versus the number of conditions. Example, children may have more than one episode of diarrhea in 1 year period. Hence it is possible to construct two types of incidence rates. So the number of children who develop diarrhea is numerator, and the number of episodes of diarrhea in children in 1 year period is the other numerator. So when there is one objective, or you should be the numerator should be specified. The exact or the contextual numerator should be specified. Therefore, this specification of numerator, as just like the numerator should be specified. Numerator for incidence study should consist of defined population that is at risk of developing the disease under consideration. It should not include those who have disease or those who are not susceptible. So individuals in the denominator should be susceptible or exposed, but not developing the disease or not developing the outcome of interest. So each individual followed is the probability to develop, having the probability to develop the outcome of interest, but not develop the outcome of interest. But also there not should be not susceptible or not exposed should not be member for this in the denominator. So denominator should be specified. The other is period of observation. So incidence rates must be stated in terms of defined period of time, either in day, either in months, or in year. Should be specified, and also it should be specified for how many days there should be identified. So one, the unit, whether it's day or year, should be specified. The other is for how many days or months they should be followed, should be identified. And to identify that, it is important to understand the natural history of the disease or that follow-up interest. It can be any length of time. That time has to be long enough to ensure stability of the numerator. Person-time denominator must be used for unequal periods of observation. Person-time denominator must be used for unequal periods of observation. As we have seen, unequal period of observation means if individuals starting and leaving the study at different time, person-time denominator should be used. But if they are starting equally, cumulative incidence or population at risk will be used. This helps to weigh the contribution of each study subjects when there is attrition, because individuals die, move away, get lost to follow up. So if there is unequal observation, we will use person time. If we are using person time, it is important to add them. The duration of time for each individual. So because if the follow-up is for 28 days, if an individual died at 10 days, that 10 day will be taken, because that 10 days that is contributed by that individual. So if allowed for 28, that 28 will be taken. So each individual contribution should be taken in the case of person-time denominator or dynamic population. Having this concept, there are also special types of incidence other than cumulative and incidence density. The other is attack rate. Attack rate is a variant of cumulative incidence, usually expressed as percent, measures the cumulative incidence of disease during an epidemic or outbreak. So attack rate will be used in the case of epidemic or outbreak. So the first we do attack rate having primary attack. We have primary attack rate and secondary attack rate. In the case of primary attack rate will be formulated as the number of new cases among population during the period over population at risk during the period times 100 or 1000. So this is similar to cumulative incidence, but the number of new cases is mostly due to epidemic or outbreak. That is a difference. The other is so we will have an example of 75% who attended a picnic. This is total population at risk. So 46 subsequently developed gastroenteritis. So 46 individuals are developed outcome of interest gastroenteritis. So 46 is the number of cases. So calculate the attack rate. So attack rate is the number of new cases, that is 46 over population at risk, that's 75 times 100. 46 by 75 times 100%. So this is finding. So the second one is secondary attack rate. Secondary attack rate is a measure of frequency of new cases of disease among contacts of known cases. So secondary attack rate is equal to the number of cases among contacts of primary case during the period over total numbers of contacts. So we will identify the number of cases that is developed by contacting with primary case or index case divided by total number of contacts times by 100 or 1000. So to calculate the total number of household contacts, subtract the number of primary cases from the total number of people residing in the household. So primary case or index case should be excluded. Then we will cause all contacts. We will collect all contacts. So total number of contacts means other than primary case or index case. So secondary attack rate calculated by this way. So secondary attack rate of 70 children. So it will express in this. Please calculate the attack rate. The other is summary. We'll have summary. So now we will compare between prevalence and incidence rate. So based on probability of disease, when we see probability of disease, percent of population with the disease is, in case of prevalence, is percent of population with disease. Percent of population with disease means the number of new and existing cases over population at risk. So percent of population with disease is prevalence. But in the case of incidence rate, rapidity of disease occurrence, the rate of disease occurrence will be measured. So unit prevalence is no unit. In the case of incidence rate is cases per person time is unit. Cases per person time meaning 100% time, 10% time. So person time is a unit. So we can also see that the risk is will calculate probability of disease. Risk also no unit. Prevalence is no unit. Incidence is person time. So risk is newly diagnosed. Risk is, by the way, cumulative incidence. So in the case of cumulative incidence, probability of disease, this is rapidity of disease. No unit. This is no unit. This is person time. Risk is newly diagnosed. Cases. Also incidence is newly diagnosed cases. Best in the case of prevalence is old cases. Old cases means new plus existing cases. So risk is an example for risk is cumulative incidence. An example for incidence rate is incidence density. So this is a difference. So incidence rate is the number of new cases of specified disease reported during a given time interval. So the number of new cases in given time interval is incidence rate. Numerator. The denominator is average population during time interval. Population during time interval. So numerator expressed per number at risk is 10 to the power of n. N is should be 2, 3, 4, 5 or 6. 6. So if average population during time interval, this incidence rate is cumulative incidence, by the way. The other is attack rate. Attack rate is the number of new cases of specified disease reported during an epidemic period. An epidemic means for attack rate. So the denominator is the population at start of the epidemic period. So times 10 to the power of n. N is maybe 2, 3, 4, 5, 6. So the other is secondary attack rate. The number of new cases of specified disease among contacts of known cases or index cases or primary cases. The population, the denominator is the size of contact population at risk times 10 to the power of n. N starts from 2. The other is point prevalence. Prevalence is divided into 2, point prevalence and period prevalence. Point prevalence is the number of current cases, new and old, of specified disease at a given point in time. At a given point in time. So the denominator is estimated population at the same point in time times 10 to the power of n. N starts from 2. So period prevalence is the number of current cases, new and old, similar. Specified disease identified over a given time interval. By the way, point prevalence and the estimated population at mid interval, or you can say at the beginning, times 10 to the power of n times 2. By the way, the difference between point prevalence and period prevalence have some identified over a given time interval, some duration or period will be considered in period prevalence, but point prevalence, it's a given point in time. Specified is at a given point in time is point prevalence, duration or follow-up time is for period prevalence. So their difference is point, their difference is time. That is a point in time, this is a duration in time. So this is their difference. Another difference between incidence and prevalence is the numerator is the number of new cases of disease during specified period of time. Prevalence is the number of existing cases of disease at given point in time. So differences, incidence is considered new cases in period of time, whereas prevalence is considered existing cases in point of time. So that is point prevalence. So existing cases means old plus new cases. The other is denominator. Denominator incidence is population at risk. Population at risk for incidence. For prevalence also population at risk. So population at risk is for incidence. So focus whether the event is new case. Time of onset of the disease is our focus in incidence. Time of onset of the disease. So in prevalence, presence or the absence of disease is our concern, and time period is arbitrary rather than snapshot of time. By the way, snapshot of time is for prevalence, time period is for follow-up, and time period is for incidence. So prevalence measures whether that disease is present or absent. The other is uses. Incidence express the risk of becoming ill. The main measure of acute disease or condition, but also used for chronic disease. More useful for studies of causation. By the way, incidence is for causation, whereas prevalence estimates the probability of the population being ill as the period of time being studied. Useful in the study of the burden of chronic disease and the implication for health service. So prevalence has implication for health service planning, and also studies the burden of that disease, the magnitude of that disease. But also incidence also a study for burden, but mostly suitable for identifying the causative agents for the disease. So the other is measure of mortality. When you see measure of mortality, now we have seen measure of morbidity, we have seen prevalence, period and point prevalence, we have seen incidence, cumulative incidence and incidence density, and now mortality rates and ratios measure the occurrence of disease in a population using different ways. Mortality rate will be calculated as the deaths occurring during a given time period or over the size of population among which the disease occurred. So you will take the number of diseases over the total population that disease is found times 10 to the power of n. N starts with 2. So this is mortality calculation. Rates whose denominator are the total population are commonly calculated using either mid-interval population or average population. So this is done because population size fluctuates, vary from time to time due to births, deaths, and migration. So people immigrate, out migrate, and birthdays will be fluctuate. So either you will take average population or mid-interval population in the case of mortality rate calculation. So this means average population means population at the beginning over population at the end of time over 2. So if you take the population if you follow for 1 year, you will take the beginning and the end of the study time. So divide by 2, you will get average population, or you will get mid-interval population in the case of rate. So we do have 3 types of rates: crude rate, specific rate, and standard rate or adjusted rate. When you see crude rate are summary rates based on the actual number of events, births, deaths, or diseases in total population over a given time period. Crude rates apply to the total population. Applies to population as a whole. So the crude rates that are widely used in description of population are crude birth rate and crude death rate. So crude birth rate and crude death rate is considered as an example for crude rates. So when we say crude birth rate, we will the number of births in the population over the total population. So we will consider the population as a whole. So this is the concept. The other is advantage of crude rates. That is the first advantage. Is crude rate gives us actual summary rate, total estimate, useful for getting an overall picture of the amount of disease in that area, calculable from the minimum information, widely used despite some limitations. So widely used means we can use for international comparisons like that. Disadvantages: it is difficult to interpret due to variation in comparison age. For instance, since it is overall summary, we cannot interpret, we cannot identify the variation within the group, the age category or sex category. We cannot identify. It masks significant differences in the risk between subgroups. Age, sex, hidden some differences between subgroups. So this is a limitation. The other is a specific rate. Specific rate apply to the specific subgroups in the population, such as by age, sex, occupation, marriage, or specific disease. So the denominator are precisely available. Age and sex specific rates can be calculated and compared between times, places, and population groups. So in the case of specific rate, the numerator and the denominator should be available. Then we can calculate specific rates, age or sex specific rates. Then it can be compared. Specific rates do not add up to get crude rates. We cannot add up. We cannot do or we do not add to get crude rates. So one does not add age specific rates to get crude rate, but rather it takes the weighted average. We can take weighted average, but we cannot add up to get the crude rate. Each subgroups will not be added to get crude rates. If you we can take the weight average. So infant mortality rate, neonatal mortality rate, maternal mortality rate are specific rates. Advantage: rates apply to the homogeneous subgroups. Rates are detailed and useful for epidemiological and public health importance. The disadvantage is it's a comparison. It is difficult to compare many subgroups of 2 or more population. When the group increases, it is very difficult or it's very tedious to compare many subgroups or more than 2 groups. So this is a limitation. The third type of rate is standardization rate or adjusted rates. Standardization or adjusted rates is used to enable the valid comparison of groups that differ regarding an important health determinant, most commonly age, so studied in different places and time. Standardization rate is used to enable the valid comparison of groups that differ regarding important health determinants. That means it can it's very important if some differences can be accounted by these rates. It is a summary rate that have undergone statistical transformation to permit fair comparison between groups differing in some characteristics that may affect risk of disease. So this is, and the 2 sentences are similar, 2 paragraphs are similar. So mortality rates computed with adjustment techniques are called standardized or adjusted rates. Adjusted rate often standardization are made for age and sex, but not limited to them. So advantage is its summary rate. Advantage for standardized rate is summary rate. It is unbiased comparison and it's easy to interpret. But fictitious rate, it is fictitious rate and absolute magnitude depends on the standard population. So aims of standardization: it can be done to increase the comparability of rates between exposure and groups. It can be done to increase the comparability of rates between exposure groups. Accounts for differing distribution of underlying characteristics, differences in particular age groups. So accounts for differing distributions of underlying characteristics. So we standardize for this reason. We have 2 types of standardization. The first one is direct standardization. The second one is indirect standardization. So direct standardization, directly standardized rates give an indication of the number of events that would occur in the standard population if the population had the same age-specific rates of the local area. Direct standardization used when the study population is large enough that age-specific rates within the population are stable. Rates are calculated per 1,000, and because rates are applied to the same population, rates across area can be compared. So in the case of direct standardization, age-specific rates of sample population will be considered age-specific rate, age structures of standard population, and summary figure is age-adjusted rate. So between 1997 and 1999, Bristol Unitary Authority has directly standardized mortality rate for accidents of 16.7 per 1,000 population. So this means that if European standard population experiences the same age-specific pattern in mortality, the death rate would be 16.7 per 1,000. So advantages of direct is, unlike indirectly standardized rates, which compare the observed number of events to the expected number of events, that means direct standardization can be used to compare disease rates across areas or time, can be used to assess a relative burden of disease in the population. Example, if there is more disease than cancer. Disadvantage: standardized rate requires age-specific rates that are not often available at local area. Rates may not be stable for small number of events, approximately less than 100. So now indirect standardization is compares actual number of diseases to expected numbers, adjusting for age and sex. Indirect standardization: when the population is small, the outcome is rare, the number of events observed can be small. This produces a ratio which is commonly called standardized mortality ratio. The expected number of diseases is taken from the number of diseases in the large reference population. So the ratio of the crude rate for the study population to the weighted average obtained is standardized mortality ratio. So what would be the rate of disease in the study population if they had experienced disease at the same rate as standard population, or the population to be standardized? So this is indirect standardization. So in the case of age structure is sample population at risk, age structure, sample population at risk, whereas in the case of standardized, age structure is sample population, age specific rate is sample population. In the indirect, age structure is sample population. So age structure is sample population at risk, whereas age specific is standard population. But in case of direct, age specific rate is sample population. So summary figure is standard mortality ratio. So standard mortality ratio is for indirect standardization, whereas adjusted rate is for direct standardization. So adjusted days rate, ADR, is equal to total expected days over total standard population times 100. So standardized mortality ratio, the ratio of the number of days observed in the study group or population to the number that would be expected if the population had the same specific rate as standard population multiplied by 100. So usually expressed as percentage. So standardized mortality ratio is equal to observed days over expected days times 100. So the question is age structure in years. This is age structure. District A population size, this one, less than 10 is 1000. District A days is 400. The number of days in the district A is 100, like all these. Standardized population is like all this. Standard population days in standard population is all this frequency, like 600, 300, 2000, like that. So this is given, but our question is that calculate the age specific days rate in district A for age above 50 years. Calculate crude days rate in district A, age adjusted rate, and standardized mortality rate. So now this is, as I told you, this is age structure. This is district A population size. This is the number of days in district A. This is age specific days rate. So 400 divided by 1000 is 0.4. So we can identify age specific days rate. Our question is, the first question is age specific days rate. So we can identify all this age specific days rate. Now standard population size, this one, standard population days, this one. For these days we can age specific days rate, we specified this age specific days rate. Now we also calculated expected days for direct standardization. For expected days now we are calculated. Expected days for indirect standardization we are calculated. So age specific days rate is, now this is age specific days rate by dividing this to this one. So this is age specific days rate we have found. So this one is crude days rate, this one is crude days rate. So crude days rate is 300 over 1500. So 300 1500. So this is 300, this is 1500. So divided 300 by 1500 is 0.5. Our question is greater than after 50 years, so 0.2. Now we have got 0.2. The other is adjusted days rate is equal to total expected days over total standard population times by 100,000. So 8,200 divided by 27,500. So this is 8,200, this one, and also 27,500. This is divided by this one, we will get 0.298. The other is this one is the last standardized mortality ratio. Standardized mortality ratio is observed days over expected days times 100. So 1000 over 1440. So this is I will show you. This is 2000. This is 2000, and this 2000 divided by this one, 1440. So we'll get it 1.389. So this is how will be calculated for direct and indirect standardization. So now crude days rate is the total number of days reported during a given time period over estimated mean interval population times by 1000. Age specific mortality rate is a number of days in the specific age group during given time over estimated mean interval population of specific age group. So like this, we will have different types of age specific mortality rate. So mathematical calculation or mathematical formula of all categories of mortality you can read by yourself. So for instance, the age specific mortality, there is under 5 mortality rate, there is neonatal mortality rate, there is infant mortality rate, and maternal mortality. So different mortality, age specific mortality rate will be found. So you can revise, you can read by yourself or by your own. So this is all about today's topic. Thank you very much for your attention. So to get the next chapter, chapter or unit is study design, descriptive study design, and analytic study design, the next 2 chapters. So to get the next chapters, don't forget to subscribe, share and like, and post your comments. So if you subscribe this channel, you'll get videos when it is released. So don't forget to subscribe this channel to get new videos. Thank you very much for following and watching this video. Have a nice time. Bye.